Here we are. We made it. Last one.
Woohoo!
Moles and Stoich, homework lecture number 11.
Yep.
We are going to do what chemists do on the regular basis when they're doing chemical reactions.
Yeah, this really does come up to be, why are we doing all this to begin with? This really is the reason why.
Right. And unfortunately, the Regents doesn't cover this a ton, but there are a couple tidbits that you are going to get hit with. So
Yes.
we got to get those to you.
Right. So
once an equation is balanced, we have to use the coefficients to make ratios, because a chemical equation is just showing you the ratio of one reactant to another to the amounts of products that it makes.
Right.
And we can use a ratio to make predictions.
right, very accurately predict, if I have how many moles of hydrogen, how many moles of oxygen, how many moles of water am I going to get?
Right.
It's not a real guessing game.
Mhm.
Once I know what I have to work with,
Mhm.
I can predict how many I'm going to come up with. Same with like making those peanut butter and jelly sandwiches
Yeah.
or those hot dogs.
It's like a cooking recipe. If you got a recipe
Yep.
for a dozen cookies, but you need to triple it, you can use the ratio in the recipes of the ingredients to triple your recipe.
Right.
Or multiply by 1.25. You can do any
Right.
multiple.
So now this is a
fraction.
little bit vague, but here's a balanced equation. It's already done.
Mhm.
Okay, it's balanced.
Yep.
Okay. Now I can make any number of ratios I want based on the 1 in front of the N, the 3 in front of the H, and the 2 in front of the ammonia.
Mhm.
I could say for every 1 mole of nitrogen I put in, I'll get 2 moles of ammonia out.
Yep, that's true. That's right. Because
That's true.
he's taking the number coefficient here that was a 1 and making
Right.
a ratio with that one.
Right.
For sure.
We're good.
And we're going to be able to use these to make units be our guide
Yes.
and do cancellation, dimensional analysis, and
Right.
predict how
We
much
could
stuff
also
will come
say
out.
for every 3 moles of hydrogen we put in, we get 2 moles of ammonia out.
And you could also take these ratios and flip them, and they'd still be accurate
They'd
too.
still be accurate.
We call them conversion factors.
We do.
And that's why we let units be our guides, and we use these conversion factors that we got from equations to do
Right.
chemistry.
Now, if we know how much reactant we have of both of those pieces going in, that was hydrogen and that was nitrogen,
The
right?
Haber process.
The Haber process. If we know how much of both of those we have, we can figure out which one's going to run out first
Right. So,
and
for
stop the
example,
reactant.
if you
Or
don't
your
have
reaction.
enough eggs when you're cooking cake, you might not be able to make a whole cake.
Right.
Or if you tripled your recipe, but you're 1 egg short, you can't triple your recipe. You can make something close to it, but not
Right.
quite. You're
And
going to run out of
The
one
picture we
ingredient
showed
first.
earlier with the hot dogs was
Yeah.
great. We ran out of hot dog buns, and so that was
You
it.
can't
right?
have 5 hot dogs. You can only have 4 if you
Right.
got 4 buns.
Right.
Okay.
So this is always a 2-step route.
And you have to run the Stoich twice. And when we say run the Stoich twice, we mean use the ratio twice to check both possibilities.
Right. You got to go from each starting material. Okay.
So both reactants to a common product in grams. The smaller the answers will reveal the limiting reactant.
Right, because that's the one I'm going to run out of first.
Right. So basically, you're doing a dimensional analysis to see which ingredients will give you the least products.
Okay. Well, here's the challenge.
Mhm.
Are you stepping up or me stepping up?
I think you should, because you
Okay.
made this problem.
Okay, take it. I will step up. But just from the words, I can write this balance equation. It says I'm going to synthesize ammonia from
Hydrogen and nitrogen. So he's going to say H2 plus N2 makes NH3. And we've got to balance it to make sure. Okay, so he's balancing it. And he sees, okay, 2 and 2, but 1 and 2. So he's got 2, 1 and 3. He's got to double the number of ammonia molecules. So he's doubling that. It turns to 6.
Whoops.
Whoopsies!
It's easy to make those mistakes.
Yes.
Very careful.
Be very careful.
So I'm just actually rewrite it now. So I got 2 N's
Yes.
and 6 H's. That's good.
Yes.
Oh, but now my N's check.
And
So
he's
now
got
I
to
just gotta
change his
triple
hydrogen,
this.
triple it.
Give this a 1,
Now.
and I'm check because this is now 6.
Right. So now he has a balanced equation to work with.
Okay, good.
And so, what's next? What's the problem?
Well, now I got to do a mole-to-mole ratios going with some information. So,
What he's going to do, so he's going to start with the mole ratio he's given. So he's going to write 5 mole H2, and then he's going to multiply by a conversion factor. He needs to cancel moles of H2 and figure out moles of NH3. So he's going to set up the ratio just like this. He's going to put 2 moles NH3 on top,
Because NH3 is what I want to end with.
because he's letting the units be his guide. He wants to get rid of the H2s, which are on the bottom, so you can put 3 on the bottom.
Moles of H2
And so basically all he has to do math-wise is 5 times 2
is 10.
divided by 3.
who is
3.333333333
3.33 moles
of NH3. 3. So he knows that if he uses 5 moles of H2, he might get 3.3 moles of NH3 out.
Okay.
Well, that's great.
Okay. I'm just gonna erase this a little bit because it's in my way.
Now, he
Now I
has
have
to
to
do the
start
same Stoich,
with
but
this.
instead with moles of H2, he's going to do moles of N2 because the problem gave you 2 different reactant ingredients, okay? So now he's going to start 3 moles of N2. He's going to set up the conversion factor that cancels moles of N2 and introduces moles of NH3, and he's taking the mole coefficients from the balanced equation to use as his conversion factor. Now he's just 3 times 2, 6 divided by 1 is 6 moles. Now, the real big question is as following. Which ingredient is going to run out first? Which one produces less of the product? And now that we've done the math twice, we can see that
Right.
he's going to run out of hydrogen before he runs out of ammonia.
Correct.
So hydrogen is the limiting reactant. As soon as all 5 moles of hydrogen are used up, we'll have produced 3.333 moles of NH3 and can't make any more.
Correct. So, again, this follows along with the practice we've done earlier. Notice I started with what I was given. Then I used the balanced chemical equation this time to make the conversion factor with what I'm given is in the denominator, what I want is in the numerator.
Yep.
And as long as I stick with that 3, the 1, and the 2,
Right.
I can make that however I want. As long as the 3 goes with the hydrogen, the 1 goes with the nitrogen, the 2 goes with the ammonia, every time I can rearrange that conversion factor however I want. And notice the 2 conversion factors I used were different because
you had to let the different units be your guide.
correct.
He started with different units, and he had to get into the same one, so he had to
Right.
pick and
And
choose.
we got some
which
muscles
factor to use.
here. We could have actually started off in grams of hydrogen, gone to moles, then gone to this,
and then gone to grams again.
yes, we can go farther. We're
And-
not pushing you right now, but you have the tools now to take this all the way out into 4 steps. Just saying.
As chemists in AP chemistry or and working as a chemist, that's exactly what I was doing all the time. How much product am I going to make in grams?
Right.
And then see if I did it right.
So this one's easy. We're just gonna do the mole ratios of this one and move on.
Okay, we're just going to do mole ratios. So you're going to write out the balanced equation for the decomposition of water, starting with an unbalanced equation. And we are going to get, yep, so far so good, Mr. Milks. We got to balance them oxygen, so he's going to add a second water molecule, mole. And he's got the hydrogens out of balance now, so he's going to get those back into whack. Got a balanced equation, and draw that 1 in there, buddy.
Got you.
Got you.
Just really want to get rid of that so you have more room to play.
So 2, 2, 1.
So now I can make any number of ratios. I can say 2 moles of H2O will give me 2 moles of hydrogen. Or I could say 2 moles of H2O will give me 1 oxygen.
Yep.
Or I could say, if I run this reaction, I'll get 2 moles of H2 and 1 mole of oxygen.
Right. These are all conversion factors that might be useful
Could be.
when
So
you are doing
The
mole-to-mole
combinations
ratio.
are not limitless, but as long as you keep the right coefficient with the right product or with the right chemical, you're good.
Do we have an actual one to do here?
No, I only want one limiting reagent for this, so we're good with that. And that's it.
Pack
We
this
just
34,
finished.
35, and 36. We finished the unit.
Just finishing it.
And the mole ratio stuff is definitely more some direct instruction, I think, for everybody to really, really get it. But it's let
but
the
that's what class is
units
for.
be your guide. And it doesn't work unless you've done your homework, because then you'll be sitting
Right.
scratching your head going, oh, what's he talking about? Let the
Right,
units
right.
be your
Well, that's what
guide.
this is for. Like we
Math, mister?
we
I
don't
quit.
expect you to have this mastered by watching the video once or even twice.
Nope.
That's what the practice is for. That's why we still come to class. We just use our class time differently. Now we use the class time to master it instead of learning.
Lay a foundation before you build a building.
There you go.
That's what
we just
homework's
did.
all about.
See?
Thanks. See you next unit. Woo! We done.